Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we are talking to Jim O'Malley, SE, Senior Principal and the COO of Degenkolb Engineers. We found Jim through an article he wrote in the Structure magazine called Peer Review in SE Practice, and in this episode, we will be talking to him about what peer review is, and how it can help move the structural engineering industry forward. I'm your co-host, Kara Green. Now let's jump into our conversation of the week with Jim. Jim, first, welcome to the show. Now, can you please tell our listeners a little bit more on the work that you do and what you do on a day-to-day basis?
Sure. Well, thanks for having me. I appreciate the opportunity to chat today. I'm Jim Malley. I'm a senior principal and the chief operating officer of Degenkolb Engineers. And I generally think of my career these days kind of in three buckets. The first is my organizational role. So in that role, I am responsible for all the operations of our 7 offices up and down the West Coast, as far as project planning, resource allocations of our staff, engineers, hiring, all those sorts of fun things, career development. And I really enjoy being part of that and being heavily involved in that. Second bucket is my technical work. And these days, I don't stamp and sign a lot of drawings anymore. We have a whole group of very qualified project managers that can do that. I act as an internal resource for them on our projects, kind of whenever they need some guidance on things, and that's primarily my internal part. Externally, I do a lot of what we call peer reviews, and we'll be talking about that in great depth here in a few minutes, where I assist building departments up and down the West Coast in approving large projects and complex projects. And then finally, I'm involved heavily with professional activities within the profession. My primary role right now is that I am the chair of the AISC Committee on Specifications, which is in charge of the building code standards for the steel industry, including the seismic provisions as well as the main specification and a number of other specifications. So that's a group of 45 professionals from the steel industry. And I've led that now for 5 or 6 years, and I'm just starting a second cycle on that. And prior to that, I was the chair of their seismic committee for about 20 years, and also involved in a number of other professional activities with the ASCE, SEI, the Building Seismic Safety Council, etc.
Yeah, thanks, Jim. That's very impressive. I know. I think that's one of the things that I just wanted to mention to our viewers. Getting involved with the profession more than just your job, but getting involved in the profession and giving back. I think it shows as an example for all the great leaders that we interview here. It's a common recurring theme, and I don't think it's just by coincidence. So thanks for sharing that, Jim.
Sure. Well, one thing just to add though is, I've always thought that I get a lot more out of it than I put into it, frankly, because I'm with people that are experts in the field, and I learn a lot more than I think I give back. So think about that if you're a young engineer, because you really can benefit from it.
And I wanted to jump into the peer review process.
Sure.
I know you wrote a great article on Structure magazine, but for those that haven't jumped into it, or even just having a more informal conversation about it, could you tell our listeners what a peer review is, why it's important, and who does the review?
Okay. Sure. So a peer review is basically a small group of engineers that have an expertise in the type of project that's being proposed to a major city, that assist the city with the review and the approval of that project, because in some ways the city's staffs may not have the expertise to verify the design that's being done. And as far as the group that does it, generally it's usually at least one practicing structural engineer. Oftentimes they'll also bring in a professor or a researcher in a specific area of structural engineering that's, again, germane to that project. And then someone also to that's expert in ground motion development, because most of these are done in the seismic world, where we're actually developing ground motions that are being put into the structural analysis models and to verify the design.
Yeah, and so maybe you can further expound about that, because I'm from Texas. We don't really have seismic, but I have heard of peer-reviewed projects, but they were very specific. They were like, these multi-billion-dollar hospitals that had to be looked after. So is there, what types of projects are reviewed, and, when are they? So when you think of like a workflow,
Sure.
some engineers come in and maybe do peer review at 30% or maybe just a certain parameter. Can you give a
Right.
little bit more information about that?
Sure. So yeah, the projects that are peer reviewed generally are going to be the vast majority of the ones we've done in the last, say, 10 or 15 years are tall buildings. And it's because the building code has some limitations on different structural systems based on their height, based on height limits, they call them. And a number of engineers have, and architects, for architectural configuration reasons, want to use different systems than what the building code allows over like 240 feet, which isn't a very tall building. So many of those projects are like that. But also, I've done a number that are just complex projects, like, for example, the baseball stadiums or football stadiums that incorporate base isolation, things like that. Those can be, or some kind of totally off the map configuration of structural configuration that doesn't fit into any category of structural system that we identify. Those can be done as well. And as far as the timing goes, the earlier the better, frankly. When really the best time is at the very, very start of schematic or conceptual design, frankly. Because the earlier that the peer review can get involved, the more impactful they can be on the design, and the less heartache it gives to an engineer if they say they come in at design development, so maybe 35 or 40% design, and the peer reviewer comes in and says, "Whoa, I don't think that's going to work." Now they've spent all this time, whereas if they'd known up front, they wouldn't have to duplicate a lot of work. So really the most important part of the whole process is that early stage where what happens is the design engineer record, structural engineer record, puts together what we call a basis of design report. And they haven't done, any real design yet, theoretically. I'm sure they've done a little bit of just testing of their models, but and they basically write their script or their building code per se for that project. And then we have to come to a meeting of the minds between the peer review team and the engineer of record. And that becomes what the building gets checked for. So it really is the key point to get everybody's kind of heads on the same page or minds on the same page, so that we don't have a lot of problems going down into the deep parts of the design.
Yeah, so it seems like the technical communication definitely early on and throughout the peer review process is definitely important to get everything going and in the right direction.
Mm-hmm.
And it looks like for these types of projects, it seems that these peer reviews aren't done for the majority of buildings. It seems like it's for special buildings, the ones that don't meet the code or not inside the code.
Right.
That's correct, right?
Yeah. Yeah.
And could you kind of go into more of what the seismic code requirements are for seismic design that you're trying to meet? Like, I think, for example, you were saying the height limit. How would that process go in terms of, okay, this building is higher than the height limit for concrete shear wall? How would the structural engineer go and try to meet that code requirement without, since it's not the code?
Okay.
Yeah.
Sure. So as far as the seismic design provisions go, what was done starting back, probably 40 or 50 years ago, they identified the primary structural systems that engineers liked to design with. And rather than many engineers on the East Coast only worry about they don't worry about the entire system as an entity, but rather the individual elements, the beams and the columns and the braces or the walls, etc., and sort of design those one at a time, if you will, simplistically. Whereas in Seismic, we really think about the entire system and the vertical elements, the horizontal elements, the connections, the foundations, everything has to be sort of defined very closely in order to for us to really feel comfortable about the entire system being able to handle, you know, a major earthquake, something that's going to happen 500 to every 500 to 1,000 years or more. So that's really a big difference. And as a result, we have what we call now a prescriptive code, which means we're very detailed about what we expect from that system and all the parts of that system and how they're going to work together. And as you mentioned, sometimes engineers want to, and the height limits has become the one that's really been called upon for these peer reviews, and partly because the building code doesn't focus too much on tall buildings. I mean, and if you think about it, less than, I forget what the percentages are, it's less than 1/10 of the square footage of construction in the country every year is over 20 stories. So, you know, you can't really build a building code specifically around that small percentage of construction. And tall buildings have different demands than low-rise buildings. So it's pretty, I mean, it shouldn't be unexpected that maybe there's a few things in the general building code that don't really apply very well for tall buildings. So that's really kind of why we've gone in that direction.
Yeah. And so, you know, you made a mention, so it's becoming really prescriptive, especially with the things that we know in regards to maybe tall buildings. But how does the process, or how do these codes allow for new concepts? Or
Sure.
I would say, how does their lack of, you know, guidance around new concepts really steer maybe a peer review committee? You know, how do y'all judge maybe something new that the designer has come up with
Sure.
to determine if it meets what is required for the design?
Right. Well, one of the things that the code has had for many years, and by the code, I'm saying the ASCE 7, which is basically the design loads code. It has had a clause in chapter 1 that says, you know, you have to meet all the requirements of this standard and all the other standards, but you know, if the engineer can demonstrate to the authority having jurisdiction, which is the building department that they're working with to get a permit, that they can demonstrate equivalent performance to the intent of this standard, then they should be allowed to do that using principles of mechanics and the like, right? So basically that opens a window or a door for engineers to step in and say, hey, I want to use this clause of the code to do something that's not fully meets the prescriptive limits or the prescriptive descriptions of the code. And so that's been in there for a long time. The recent editions of ASCE 7 now have some more guidance on performance-based design, which is what we're that's kind of the next generation, if you will. Because right now the prescriptive code is either, you know, you meet it or you don't. It's supposedly a bright line, although all of us know that there's all kinds of gray to determine that. But it's like, you know, a thumbs up or thumbs down, whereas performance is a whole spectrum, right? And so that's what the engineers are doing. And so when they want to do these performance-based designs, or this, you know, using this clause that says that as long as I can just demonstrate equivalent performance to the authority having jurisdiction, that means they're going to have to jump through some extra hoops, right? Or it's a little bit higher bar for their design possibly than what the standard code-based design to meet the, you know, the prescriptive provisions is.
And just to further ask a question about that, as someone who does peer review, specifically maybe around seismic. So let's say there's a new, you know, performance-based seismic bracing, you know, system. So when you're in the peer review solution, I always assumed peer review was, you know, experts in the code. But if you're performance-based and it's a new concept or a new technology, you know, how would a peer reviewer or a peer reviewing company analyze that if they don't have the expertise per the new technology?
Right. It's a good question. Generally, what we don't see like wholesale brand new, completely out of the box, right?
Yeah.
We're sort of incremental, right? I mean,
Mhm.
so it's something that's probably something like we've seen before, if you will, and just kind of a new step or something like that. So generally, um, that's, you'll find some people that have expertise. And the other thing is the research, right? A lot of these new things are coming from research that's been supported by industry or maybe the federal government. And that's how a lot of new things get into the building code or into our standards over time. So many of those, and in many cases, there'll be multiple researchers working on a certain topic. So that those folks could be part of the pool of peer reviewers as well. So that's, like I said before, a lot of times having the research side and the practicing engineer side gives a nice balance. The researchers can really, poke at any development work that was done, because that's kind of what they do, in their research as well.
Yeah. So in terms of, for example, maybe rocking core shear walls that are made out of CLT, something
Sure.
that's kind of new, but not, but it's not in the code essentially. And
Right.
so in that case, you probably have the code experts, such as yourself, but maybe having some researchers that have done testing on that type of structural lateral system before. And then you guys would kind of, I guess, go through that whole process, right? Something.
Yeah, absolutely. And so again, and in something like the new CLT walls, we do have, there was developed not too long ago a provision based on a FEMA sponsored document, which was called FEMA P695, and that provides a roadmap, if you will, if you do have a brand new system like, say, a CLT shear wall and a rocking system, that of what you need to do from a testing perspective, from an analysis perspective, and how you craft the description of that system. So that gives us a much better way now to kind of go through that process as we look at a brand new system. So and that would end up having, a new line in the code eventually that says, okay, rocking shear walls, they'll have a height limit, they'll have, R factors and all the other design parameters based on this whole P695 analysis. And that's not reviewed by just a small group. That's reviewed by a very big group across the entire industry. And there's like, 3 or 4, probably two to 3 years worth of meetings with that group to kind of do a brain dump and demonstrate that new system deserves a spot in the building code.
That's a lot of cooks in the kitchen to get stuff like that in.
Yeah, if you want a whole new system, that's different than just an individual building. So it's a different bar you have to go through. But the code does have a process for making that happen.
Could you go through an example of the process for let's say a typical high rise that you're peer reviewing? What's the process like for the teams involved, the structural engineer of record and the peer review? Is it a back and forth, or how many times do you guys meet? What are the comments?
Sure. Yeah, it's definitely back and forth. And like I said, the earlier the better. Get that basis of design in place, have everybody agree to it, and then basically then you just kind of reviewing the documentation of what they've done to demonstrate they've met all the facets of the basis of design. We look at usually preliminary analysis, just a linear analysis, kind of standard stuff. We'll look at then almost all these projects include nonlinear response history analysis, which again, that's the high bar jump, right, over a standard elastic analysis that we do on most of our routine projects. So there's a whole host of assumptions that have to go into developing a nonlinear analysis model. It's like an order of magnitude more complicated than our standard, ETABS or SAP analyses in the linear world. And so before they, push go on that nonlinear model, we also want to go through all of their assumptions and make sure we agree with what they've assumed to put that model together. Because again, those things probably run for a week or two before they complete. And now there's, a terabyte of data to deal with. And we don't want them to have to do that more than once, or if maybe they'll have to do it a couple times to respond to comments, but not to start all over again because we don't agree with their assumptions. So again, cutting off having disagreements prior to doing major analysis. So we'll review the nonlinear analysis multiple times to kind of fine tune the final design, look at all the drawings in detail, especially as they reflect the major elements of the seismic system. And then sometimes they have multiple phases. A lot of these projects have like a foundation package before the superstructure gets approved. So we have to sort of sign off that the foundation design is, because they're still doing the final design on the whole superstructure, that it's conservative enough that we're comfortable that there won't be any major changes to the foundation once the superstructure design is completed a couple of 3 months, 4 months later. So that way they can start excavating and pouring concrete before they need to have steel or concrete for the shear walls on site.
Yeah, that's great. So maybe you can provide a little bit of input. Do you have an example of a project where they brought in you as a peer reviewer early enough to maybe catch something exciting or to help maybe facilitate an easier project process? Do you have an example of maybe just a really successful project where they brought you in at a good time?
I do. And I can talk, I think, about these projects now because since they do go through a building department, that it's all sort of, a lot of our process is documented in the building department, so it is public record at that point. There was a project down in Los Angeles that's now, I don't know if it's open yet, but certainly the structure is complete, called the Wrapper Tower, and a very unique system, like nothing I've ever seen before. It's not a brace frame, it's not a moment frame, it's something different. And it kind of looks, I don't know if you know the Bird's Nest Stadium in Beijing that they had the Olympics.
Oh yeah.
But it's that type of structure with built up boxes that sort of wrap the building, and that's why they call it the wrapper. It's very close to the Newport-Inglewood Fault in Southern California. And I was reviewing it with Professor Steve Mahan, who unfortunately passed away not too long ago, but and so complicated that we weren't sure how they were going to demonstrate this building was going to work unless they base isolated it. And so when we left the first peer review meeting, they had the design was for what we call fixed base design. And so we were flying back and we both were looking at each other saying, boy, I don't know how we can approve this unless it's base isolated, because the base isolation would reduce the demands on that very complex, unique structure to the point that we felt like, well, it would essentially remain elastic above the isolation, and that they could analyze and demonstrate would perform properly. So we basically kind of hinted at that at the end of the first meeting that, guys, I think before we talk again, you may want to think about base isolation. And we came back into the meeting thinking, okay, if they don't say they're going to base isolate it, we're going to say, we don't know how you're going to improve it otherwise. But they took the hint. And when we walked in, they said, since we talked last, we've decided to go with base isolation on this. And so I think that was the best decision they could have made for that structure. And again, it's up and hopefully running very soon.
Very cool. Yeah, that's interesting to see how those, because I know behind every project that's of those complexities, there's that whole peer review process, design process, the coordination that goes into those. And I don't know, I sometimes call them war stories, even with the simple or simpler buildings, but I can imagine the process going into these peer review projects that are that complex.
Right. And the the design team and the owner developer need to recognize that they need to have a band of time to allow that process to happen, right? I mean, it's going to take a little longer, but it gives them the opportunity to do things they couldn't do otherwise, right? So there's some cost involved, but I think fairly minor compared to the value of some of these major buildings that are being put up.
Yeah.
Thanks. I do have to, sorry, I got to drop off right now, but thanks so much, Jim. And yeah, really interesting. And thanks for coming on again.
Absolutely. My pleasure.
So when you talk about peer reviewing, there is a small associated cost, but I think those large buildings and the budgets around large buildings do absorb it in some way. But, there's also a benefit to the construction industry just in whole, because I mean, it's always good to have someone look after your work or just look it over, especially if they have expertise in it. So how, since you have experience with peer review and how it's impacted projects, how do you think peer review could maybe move the construction industry forward?
Well, I think it does. I think it helps to, as we talked about the rocking shear walls, another new system that is being pushed pretty hard in the industry now, is what AISC, the steel industry, is calling speed core, which is a composite system of steel plates and concrete, and that wouldn't have happened on a project unless it had been peer reviewed. There's the Rainier Square project up in Seattle, which is I think the second tallest building in Seattle now, uses that system, and I was lucky enough to help with the peer review of that, having been involved a little bit with the development of the provisions for that, as well as the research that had gone on. And I think that's where a lot of the innovation can come from, and it's not the innovation per se, but it's the confirmation that the innovation kind of meets the standard that everybody's agreed to, right? And that, I mean, we need as a profession to be comfortable with that, and that that people have looked at it with another sets of eyes, and given it that second look over. So that, because what we do impacts the lives of lots of people, right? If something goes wrong, which never want to talk about, but people's lives are at stake because they're in these buildings potentially when a major earthquake would hit. And when civil engineering and structural engineering, that's the primary goal, right? Is that life safety. So having extra time and deliberation for new innovations is important, but also giving comfort to the building department that, hey, yeah, we're fine with doing this, a permit for that. And the engineers from the building department all take part in the meetings, and so they're there throughout the whole process to make sure that it's kind of what the type of process that they want and they're comfortable with, in order for them to go forward as the building department, saying, yes, this building can be built in our city.
Yeah, and I think that's a great point to make, especially I feel like there has been a big technology. I hate to call it a boom because there's rarely a boom in the AEC industry, but, we've seen a lot of new things come about. Matt mentioned the CLT, you mentioned the rocking shear wall, which I just, I'm not super familiar with seismic zones, but I'm just now starting to hear more about it. And so it's good to know that there are experts that are looking these things over.
Right.
And so, just to end off here, do you have any advice? You had a very involved career, and now you're to the point where you have such an expertise to where you can provide, a significant amount of value to design firms, as well as, you mentioned just city planning committees, just city planners in general and reviewers. For young engineers who, you've had a lot of success, what advice can you offer them, maybe to observe some of the success that you've seen? Because you have like a laundry list of amazing accomplishments. And I think it can be intimidating for younger engineers, or even engineers maybe not as involved in the industry as maybe they would like to be.
Sure.
where's a good starting point to really see the successful track that you've seen?
Thanks. Well, just first, I think a lot of it is really raising your hand and saying, I'm interested in participating. And most all of the states in the country, and in California, we have 4 regional groups of what we call our Structural Engineers Association. And many of us cut our teeth and started working on local committees. And again, you raise your hand, you deliver, you say, I'm going to, do these, say, case study designs, you do them. People say, go, that's great. We look, and then they'll ask you to do another thing. And if you keep raising your hand, they'll keep asking you to do more things. So I think that's a big thing. And it's not for everybody, right? I mean, it is outside of the work, your day job, if you will. But the other thing is, I've found, it certainly was my case, and I think it's true today, is that structural engineers as a profession are very willing to share their knowledge. I have friends that, like golf buddies, that there's lawyers and there's doctors and, other professionals and accountants. And I tell them about these conferences we go to, and we tell each other what we're doing and why, and all these new things that we're sharing together. And they look at me like I'm crazy. They said, why would you ever share that? I mean, you're giving up your special knowledge. And I could go back and I said, well, again, life safety, right? We're all together on this. There's no, you can't cut that short and just feel like you're going to be able to hide something. And we work with a building code. They don't work with building codes, right? So that, I think, is different about us. And as a result, I think you'll find young engineers will find that within their own company, their principals or things within their own company, or outside, go to an structural engineer's monthly meeting and, get a beer and chat with some engineers from other companies. And there are going to be, I can almost guarantee that they'll be totally open to talking, learning about what you're interested in, giving advice, that as far as their career and what, you could make of yours. So I really think it's a great profession in that way. The other thing is it's a great profession as far as your ability to continue to grow and develop and bring value every day of your career. It's something that it's to me, very gratifying that you can take part in these things and feel comfortable about the designs you've done and how they're going to perform, or the ones you've reviewed as well. So from that perspective, I always encourage engineers in our company to be inquisitive, ask questions. Don't the door's always open. Go ask a question. Doesn't have to be related to a project. Could be, what are you thinking about for your career development? And do some long range planning. Don't just think about the project that's in front of you, because it's your career, right? I mean, and it should be your company and you should be sharing that and like partner. I always call it a partnership between our staff engineers and the company as far as their development, and because we want them to turn into great engineers and be the next generation that pushes our profession forward.
Oh, that is such great feedback. And I think our younger engineers who are listening, I would even say even our tenured engineers, I don't consider myself a young engineer, but I am one. I think they really appreciate hearing that. And I think one thing, and it was kind of mentioned, is just like that open communication. I mean, you talked about it before, getting to your position and being able to give that feedback to the one company about the base isolation and for them to take it on and then change their building structure. I mean, I just think that's really important. And I think, once you reach that level of communication, just having the knowledge, but to gain the knowledge, you also have to have the communication. So
sure, absolutely. It's a two-way street, no question.
Yeah, exactly. All right, Jim. Well, thank you so much again for your time today. It was great to have you on, and it was great to hear your perspective.
My pleasure. I really enjoyed it. Thanks.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, which is episode number 81, as well as links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.